Well, hi, everybody. I see Ashley and McKinnon are on. How are you guys doing?
Good. How are you?
Doing well.
Good.
Yeah, kind of a crazy time for me at Great Falls High. I'm sure you guys have all heard.
Yeah.
Uh-huh. So anyway, we will get through it. So let me grab my notebook really quickly. Hi, Marka. So did you guys enjoy having a week off?
Yeah.
Yeah, I did.
Awesome. Okay. Well, let's go ahead and I wanted to just real quickly, I have a couple questions. I guess one main one. Were you able to get the textbook?
Yes.
Yeah, I have mine.
Yeah, I got mine.
Okay. And were you able to just get it on Amazon then?
I did an ebook
Yeah.
through the website.
Okay, good. Okay. So that was maybe a little bit less expensive, I hope.
Yeah, and then you just like got it right then and there too.
Okay. Nice. How about McKinnon and Ashley? Were you guys able to get the textbook as well?
I got mine. Yeah.
Yeah.
Perfect. And did you guys do the ebooks or the hard copies?
Hard copy.
Yeah, I got a hard copy off Amazon.
Okay. And was it about $90?
Yeah.
Okay.
Yeah, like 88 or something.
Okay, that's what it was when I was looking as well. Okay. Well, I think you guys will like this book. It's kind of simple. I like that. It's not too wordy. So I think it's to the point, really what we need. So, okay. Well, a couple of things I wanted to just ask you guys about last week the two slides that I left off. Let me go back to that presentation really quickly because we were talking about characteristics of scientists and then really thinking about how our attitudes might affect our ability to teach. So let me just share this screen. I don't know if you guys had a chance to look at this, but let me go ahead and just share this. And I'll just put it on present. So the first slide here is your personal attitudes about science. So like, let's just kind of look through and I want you guys to think about where you might place yourself, your personal attitudes, the good and anything in between to bad. And then meaningful or meaningless. So why don't you guys, I don't need to read them to you, but why don't you read through, oops, oopsie daisy. There we go. And then let's just talk about where your check marks or where you would be on which side of the spectrum, or were you mixed or in the middle, or what would that look like? So I'm going to give you guys just a couple minutes to do that. Just give me a thumbs up, why don't you, when you're finished. Oh, except I can't see McKinnon and Ashley. Okay. All right, awesome, you guys. So who wants to start? You want to share where you were in that spectrum about your personal attitudes?
I feel like I was more on the left than the right.
Okay. Is that Marka?
Yeah.
Okay. Okay, great. How about, let's go, McKinnon, you want to go ahead and go?
Yeah, I kind of the same as Marka. Usually like either A or B was where I felt like I was at.
Okay, cool. And how about Ashley?
I felt like it depended on like the grades. Like so for elementary, I feel like I was more like on the A side, but then as I got into high school, I didn't feel so much on the A side.
Okay, were there specific ones like the meaningless or monotonous, or was it just pretty generally a lot of?
Yeah, I feel like yeah, just a lot of them because I just didn't have a good experience with science in high
Okay.
school.
Yeah, and that's, that happens to a lot of people, unfortunately, but you can see maybe how it might ruin your thinking about science as a whole. Okay, let's go to the next one, you guys, because this is about your thinking about you teaching it. Let's just go ahead and go through the same thing. Ah, sorry. And again, if you just want to give me a thumbs up when you're ready. Okay, let's go again. What do you guys feel on that one?
I feel like I was the same just because like science is one of those things that you can go through so many routes with that like it makes it interesting. But yeah, I feel like I was still more towards the left.
More towards the left. Okay. How about McKinnon?
I felt like my answers were pretty much the same as before, but kind of like Ashley was saying with the grades, I feel like it might depend a little bit on like the subject too. Like how comfortable I am with it would definitely like change some of these answers.
Sure. So would it depend on what grade level of science you were teaching?
Yeah, probably grade level.
So are you thinking like the upper grades, like maybe intermediate to middle school, you might be a little bit more middle to right?
Yeah, I think so. Like definitely more in the middle.
Okay. Because you think the content might be more difficult?
I just know that like I struggled with some of it, and so like based on that.
Yeah. Yeah, that's totally legit. Yeah. So you're not worried about like managing the classroom or materials or anything like that, more just the content.
Yeah, more content based.
Okay. All right, Ashley, how about you?
I would agree with McKinnon, but also that I feel like you as a teacher can make it a better experience. Like even if you didn't have a good experience, you could always just make it a better experience for your student. So I'd be more on the left for that.
Okay. Yeah, I mean, I think you're right on there, Ashley, is if you have that level of uncomfortableness, the kids are going to pick up on that. Plus, you are not going to probably teach as much science. You're not going to go into as much depth. You're not going to provide maybe as many opportunities. So it's all about really, in a lot of ways, your comfort level, whether it be the subject or the management, or just if you look at it as just a pain in the butt because you got to get everything ready and then there's the cleanup. And so some people view it like that too, where it's just too much work. They don't want to mess with it. But you will soon find that it is elementary students usually one of their favorite subjects besides recess, because they get to do stuff. So, okay. So that, I just wanted to really touch on that. It's kind of an inventory for your personal versus your wanting to teach, and see if there was any connection, or, how that you felt about that. Okay, so that was the end of that. All right, let me go ahead and let's go to our new presentation. I'm going to just check real quickly and see if we've got a, let's see, whoops. We'll stop the share here for just a second. Okay, so we might get, I think it was, let's see. Was that you, Marka, that texted me?
Yeah, it was.
Okay, so Jenna's going to be here in just a minute then, you think?
Hopefully. I think she said she was at a doctor's appointment.
Okay, no worries.
But,
Okay, just
yeah. And then did Taylor get a hold of you?
no.
Okay, she told me that she got called into work,
Okay,
so she wasn't gonna make it. Yeah.
okay, okay. So, and I don't know if you guys have wanted or looked, had any desire or needed to look back at the recordings, but I did. It takes me, I have to upload them to YouTube and blah, 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 get the link to that, and then I put them on Moodle for you. So if anybody needs those recordings, they're on there, which it might be kind of boring, honestly, but at least you can get the information. Hi, Jana.
Hi. I was talking and I was like, oh, I'm muted.
That's okay. How are you doing tonight?
Good. Sorry, I had an appointment and I didn't think it was going to be that long.
No worries. No worries. Thanks for joining us anyway. We were just talking about kind of a self-inventory about our attitudes about teaching and our attitudes about, or excuse me, about teaching science, and then our personal attitudes about science and how that might have an effect on how we teach it and how our kids would accept it. I'll show you here. I can just show you super quick, just to kind of catch up a little bit. So we just went through and identified like where we might be with these items for, again, our own attitudes, our personal attitudes about science. So Jenna, where do you think you'd lie on that spectrum? Would you have like a lot of checks maybe in the middle, on the left, combination, or on the right, or, you know?
Probably the middle, but I feel like in some areas it would be kind of like scattered maybe.
Okay. And is that based on your own personal scientific experiences?
Yes.
Like how you learned it and how you were taught?
Yeah.
Okay. And then this one is about, so thinking about that, when you think about teaching a science lesson or teaching science, you know, some elementary teachers are responsible for teaching that science content for, you know, every day or 3 times a week or whatever, whereas some teachers will team, and maybe you would be the science social studies person and your teaching partner would be the math ELA or whatever.
Yeah.
So how would you feel about teaching science?
Fine. I think having a past experience that would like teach you a lot on what not to do or like what to do or like what you liked and what benefited you in the classroom.
So maybe some of those experiences that weren't so positive, you'd remember that and go, oh my gosh.
Yeah.
Yeah. Yeah. Okay, good. And that's kind of what we said too, is that, you know, you'd maybe want to obviously make it a more positive experience if you didn't have one. And I think the other 3 gals that are on said they'd be maybe on the left on this one, but a couple in the middle, right, you guys? But I was saying how science is really such an engaging subject for elementary kids because you usually get to do stuff. and they like that. You know, they really enjoy that, and they're curious. They're naturally curious. So, okay. So there you go. You're caught up, Jenna.
Thank you.
Yeah, you're welcome. Okay. So so let me go ahead and pull up to tonight's presentation, and I'll go ahead and show you here. Let's see, not that one. This one. Can you guys all see that?
No.
No, I didn't share it. I didn't think so. Sorry. We'll have this down by the end, won't we? There we go. Okay, so just a couple of things tonight that I really want to stress. When you're learning about science and what is it, it's really important, I think, to understand the big picture and the purpose of why is science important? Why are we teaching it? And so tonight, what I'd like to do is, oh, that was the question, Jenna, I asked, or I asked everybody, is did you guys all get your textbooks?
It's ordered, but I don't have it.
Okay, but you should have it in a couple of days.
Yeah, I'd have to go on and look when the delivery day was.
Okay,
Might have
cool.
been Friday. I can't remember.
That's fine, no
I have
worries.
4 coming, so I can't keep them all straight.
Okay, and there's just one assignment out of the first chapter, so.
Okay, I'll
Oh.
just get it from some.
Yeah, you can do it this weekend even, because there's a couple other things that everybody can be working on.
Okay.
Okay, so tonight I really want to focus on really what is science, how does it work, what's the process, why should it be taught in school, and what does it mean to be scientifically literate? What does that mean? And, you know, why do we care? So that all has to do with this concept of the nature of science. So this is, I thought this was kind of funny. I threw it in there for you guys. So we've come a long way, right? We, you know, I mean, you think about it, it's like, well, yeah, how come they only did live till 30, you know, or not even to 30? But we've made tremendous strides in technology and our understanding of the natural world, which certainly helps us with, you know, our lifestyles and making life a lot easier. So what I have tonight, one of the things I would like you to do is, and I don't know if you were able to print it, it doesn't matter if you weren't, you can just read it on your screen. It's an article in Moodle. Did you guys happen to see any of those?
I haven't looked yet.
Okay, you know what, it might have been in, I don't remember if it was in week 2 or if I put it in week 4, but it's an article about Walter Alvarez, and the copy I brought is just a white one. I'll show you. But what we're going to do is we're going to do a jigsaw. Have you guys ever done a jigsaw strategy for reading? Okay.
Yeah.
Jen, you're nodding your head. Do you want to tell us what a jigsaw is?
Wait, did you say Mark or Jenna? I heard yeah from Marka.
Oh,
Sorry, I was so confused.
I said Jenna because you were nodding, Jenna.
Oh, yeah, I was going to ask you, is that the one where you connect the words, like you have it going this way and then you connect them this way?
No.
Oh, just kidding then.
Okay, no worries. Has anybody else heard of or done a jigsaw strategy in terms of reading? Okay.
I've heard of it, but I don't know what it is.
Yeah, I think you guys will really like it. So this is a fun one just because it kind of breaks things up. I'm going to unshare my screen and I'm going to hold up this document. So again, if you don't have it printed, no worries, you can just read it on the computer. So let me just show you what it looks like here first of all. So I'm going to let you guys find it on Moodle and pull it up. If you don't, you can just download it.
That's not on this week's.
I think you have to go under How Science Works folder.
Yes, it is under the How Science
Yeah.
Works
Okay.
folder. Okay, so why don't you guys do that for just a second, and and then I'll tell you what we're going to do next. Okay, what I'm going to ask you to do right now is just look at the title, and I want you to think about, predict what you think this article is about. And then I'd like you to just do a quick skim. Don't read it very carefully, just do a quick skim and try to see if you can get an understanding maybe of what this article might be about, a preview, and then we're going to talk about it. Okay?
Okay.
All right. Thanks, Marka. Did you guys get this one printed or made?
Yes.
Okay,
I have it made.
it's fine. You don't have to have it printed. You can make them by hand. But this is so nice on, especially on these Zoom calls. And if you guys end up teaching a distance learning, you can, tell the students to, I want you just to put a yes or no when you're finished, or just a yes, I guess, when you're finished. Okay, Jana, how about you? Are you getting there? Oh, she's got it. Okay, perfect. Okay, so let me tell you guys a little bit about what the jigsaw is. And I don't know if you've taken a reading class, but when you introduce a passage like this or whatever, a chapter or something that has a bold text, a text feature, okay, you really want to ask students, have them predict, what do you think this is about? And what makes you think so? Why do you think that? Be sure you ask them questions. And I'm sure, have you guys, how many of you have taken a methods in teaching reading?
I have.
Who said that?
McKinnon.
McKinnon, okay. So McKinnon, when you took your class, did you learn about text features in the book? Text features, articles?
Like the bolded text and stuff like that.
Exactly. And for those of you that haven't, I'm going to just show you because so many of our students struggle with reading. And as we know, if you can't read, it makes school really frustrating, which increases your behavior problems, which, I mean, it just goes on and on. So one of the things that I have my students, even in high school science, is I'll have them, first of all, just say, I want you to list as many text features as you can. Okay, I want you guys to do that right now, just on a piece of scratch paper. List as many text features. And McKinnon gave an example, bold text. As many text features. Okay, here's another strategy for you guys. I'm just full of them tonight, apparently. Okay, so I'm going to list some and then I'll show you how this works. Okay, so here's my list. And what I want you guys to do is with your list right now, I want you to just draw a little squiggly line under your last item. Okay. And we're going to put an LOL. Does anybody know what that LOL stands for? Well, laugh out loud. But besides that, it's a line of learning. Line of learning. This is a really good strategy to do whole group, or if you have students working in partners and then whole group, or if you just want to go from individual to whole group. Does anybody want to make a prediction about what they think this LOL, how we're going to use this?
Is everything after it stuff that other people say that you didn't have written?
Exactly. Yes. So this is my individual stuff. And then as people are saying ideas that I don't have, I'm going to add to my list. Okay. So it's called a line of learning. So you can have students do it individually, then partners, and then whole group, or just individually and then go to whole group. Okay. So this would be another strategy to add to your strategy page in the back of your notebooks, right? Line of learning. And you can, I mean, this is a good strategy for any subject when you're brainstorming or coming up with ideas, a brain dump, whatever you want to call it. It's a great one to just share and have everybody feel safe and like they're contributing. Okay, so let's just go ahead and Jenna, why don't you share an example of a text feature?
I did the points that are listed on the second page that are all in bold.
Ooh, so like bullet points.
Yeah.
Okay.
And they're bolded.
Ooh, okay. So let me give you an example. So I don't have that on my list. So I'm going to add bullet points. Okay, excellent. Thanks, Jenna. How about Ashley?
I put pictures with captions.
Ooh, awesome. Pictures with captions. So if you don't have that, you're going to add it down below. I have pictures with text, so kind of the same thing. So I'm not going to add that, but if you don't, add that to yours. Okay, McKinnon.
I said like summaries in the back of a chapter or at the beginning
Ooh,
of the chapter.
yeah, summaries at the back, or like I think it would be at the beginning, maybe it's like the big picture, the goal or the objective kind of. Okay, so two separate things really, summary and kind of a preview. Okay, excellent. So add those if you don't have summary at the end of the section, and preview. Okay, excellent. Marka, how about you?
I put like the questions that they ask at the beginning of the story.
Like pre-reading questions?
Yeah.
Good one. Okay, I'm going to share one I have. Highlighted words. Okay, Jenna, another one.
I put bold text.
Okay, bold text. Excellent. Ashley.
I put graphs.
Yes, good one. Graphs. Mm-hmm.
Yeah, data.
Data. Graphs, tables. Mm-hmm. Super. McKinnon.
Titles like of chapters and then of like
Subtitles.
paragraphs. Yeah, subtitles.
Yes, titles and subtitles. So like key ideas and then details. Very good. Okay. Marka, you got another one for us?
I put like keywords, which could probably be like the same as highlighted words, but
Mm-hmm. But they
just all those words
sometimes
are gonna.
have the, yeah, they sometimes have like the vocabulary listed at the beginning of the chapter, like on the margin of the page or something. Okay, yeah, so vocabulary, keywords, good. What else, you guys? Italicized words?
Yeah.
And underlined, I had that as well.
Yes, yes. A couple of things that most people don't think about are the glossary, appendixes, and the index. Those are all text features that help you. A text feature is something that's going to help you understand the text or the information in the textbook. Okay, so the glossary, index, and any appendixes. Okay, and you guys, even in the high school, I do a whole thing on text features, and I use that term very often because, again, I have a lot of students that struggle with reading. And that just helps them either break down, helps things jump out at them, and if they understand that the way that that is organized. Sadly, this article does not have a lot of text features other than the title and the bulleted list. And I guess there are some bold words, aren't there? Okay, so not a ton of text features, but those are important things to look at, okay? So sorry about that little diversion there off of text features, but that you can use that in any subject, right? Social studies, anything. And I would take time to orient your students to the resources you're going to use and point out those text features, because it helps them get an understanding of where to find information, how to understand the information. Okay, back to our original strategy, the jigsaw. What you do with a jigsaw in a big classroom is I would go around the room and I'd number 1, 2, depending on how many chunks of information I'm going to break the article in. Because there are 4 of you, I'm going to break this into 4 sections. Okay, so you'd want to predetermine that. And I was going to wait until I saw how many of us there were tonight. Had there been 6 people, I would have divided into 6 smaller pieces. Okay, but I'd go around the room and I'd say 1, 2, 3, 4. You're a number 1, you're a 2, you're a 3, you're a 4, and so on and so forth. And then I would have all of the ones get together and they would read their section together, highlight key ideas and details, and discuss what are the things, the important things or key points that I want to share with the group. All the twos would get together with the same article and read their section or their chunk and highlight and determine, what's important, what should we report to the group? So they become the experts on that particular section. Okay, and then I'll have them share out, like say, okay, group 1, you guys had paragraphs 1, 2, and 3. What can you tell us? What was that section about? Okay, does that make sense, you guys? As far as what a jigsaw is? Okay, so we're gonna do a mini jigsaw because there's only 4 of you. So instead of, you're not gonna be with groups of students, you're gonna be specifically in charge of your section. You're gonna be the expert. So let's see here. I am going to have the number 1 person, whoever that is, who wants to do the first part.
I'll do it.
Mark it.
I will.
Go.
Too many. Let's do a, raise your hand. Okay, Jana, you're gonna do section 1. You're going to read paragraphs 1 through 4. And when I do this in front of the class, I'll literally like put like this and actually have a copy for each student to write on, to annotate. Do you guys know what it means to annotate on an article? What does it mean to annotate an article?
Would that be like taking notes on it?
It would be like taking notes. What we do at the middle and high school here in Great Falls, I'm looking, I don't have any highlighters with me, but we do a highlighting sort of a strategy where green is the topic. So in this case, this would be highlighted in green. And then the key ideas are yellow and the details are highlighted in pink. And it's really effective. The middle school teachers do a phenomenal job. So by the time we get them at the high school, they're very proficient at that. And it's not too early to teach that in like 4th, 5th, and 6th grade. As you teach writing, you're teaching about key ideas and details. So if you guys want to try that, another one is underline 1, circle a few. It's another annotation, but yes, you're taking notes off to the side, you're highlighting, you're underlining key things, but however you have kids annotate, make sure you model that for them. Okay. All right. So the second section, who wants to do part 2?
I can.
Okay, McKinnon, you're going to do the last paragraphs on page 1 there.
Okay.
Okay. Can you guys read that okay? Okay. Okay, section 3. I'm going to split it between Mark and Ashley, okay? Okay, so we'll make it kind of simple. Section 3 is going to have the evidence, and section 4 is going to be this last part. So you guys can fight over who wants to be a 3 and a 4.
I can do 3.
Okay. Ashley, you good with 4?
Yep.
Okay. All right, so here's what I'm going to do, you guys. I'm going to give you some time and to go ahead and read this and have ready what it is you're going to share with the group. Please don't read it from the paper. In your own words, be able to tell us the section that I read explained blah, 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 blah. Okay, now especially Ashley, you might have to go back and read some of the other to sort of understand your conclusion, right? It might not make sense to you just by reading that going, okay, I'm totally lost, because you don't have the context of the rest of it. Okay, so if you need to do that, you're welcome to do it. But your job is you're going to be the expert you're going to teach us and fill us in about the rest of this. So to signal that you're done, what I'm going to ask you to do, go ahead and you can turn your camera off right now, but when you're done, you can just turn your camera back on, and then that'll tell me and everybody else that you're done. Okay? So go ahead and turn your cameras off, read, annotate, get a little script ready to read to us, okay? Okay, you guys. Okay. You guys look like you're ready to go. So let's start. Let's see, McKinnon, you had number 1, right?
I had 2.
Oh, you had 2.
I had one.
Jenna had 1. Okay. So Jenna, can you give us the
So-
scoop?
Yeah, I did bullet points next to each paragraph of like important things.
Okay, perfect.
So the first paragraph, it talked about, I don't know how to pronounce his name.
Alvarez, Walter Alvarez.
I'll, okay.
What?
He was looking and he noticed that there was like these weird layers and patterns in rocks. So he noted, and then he also noticed that there was clay. And he just like formed a bunch of questions that he had. And that covered like each of, I like that each of his paragraphs ended in a question, like more questions that he had about like his like the rocks and stuff like that. It was something I really liked. And then paragraph 2 talked about he wanted to know when the clay like became part of the rock and like why it was there. And then they talked about he met up with his dad who did physics, I think it said. And they wanted to see if there was if it was like a correlation with beryllium, which they thought that it was like the more clay, the more beryllium, and that was like the longer it had been around. But that ended up leading them to a dead end. And then paragraph 3 talked about just them bringing in some more scientists that they thought might like help them and answer more of his questions that he had. And is what they for scientists is that they found 30 times more of iridium in each rock. And then the 4th paragraph had like a lot more questions and stuff in it, but he wanted to figure out where that dust and stuff would come from that they found in the rocks and where they would find iridium. And the place that they found the same like amount was Denmark. I think you're muted.
Sorry. Yes. Okay, excellent. So just to give you a little more information on the beryllium, so they can use some of those elements and look at the amount of decay that they see, like, so they can use it as like a timer. So I want to show you guys a slide. Jenny, you did a nice job on that. Let me just pull up this presentation here. Here we go. To give you an idea of what she was talking about, this clay layer and who was Walter Alvarez, what does he look like? So I'm going to share my screen with you. And I put a couple of pictures in this presentation for you. Do you think kids are going to want to know that? I mean, this is obviously more of an upper level, high school article. It's not for elementary. There's no pictures. I mean, it's just a lot of text, right? Yeah, I mean, it's hard for me to imagine. When I start seeing pictures, I get a little bit better idea myself. How about you guys? Okay, so here, this is Walter Alvarez on the right, and this is his father, Louis. And this is this clay layer here that they're talking about. How did that get in there? Okay, what is this clay layer? Note that Walter's holding a rock hammer in his hand. And this just gives you a close-up view. So you can see the layer is not very thick. And another thing you may have read that, Jenna, is that they noticed a great deal of marine fossils below the clay layer and less marine fossils above. Okay, so that was kind of interesting too. And so do any of you remember anything about the geologic timeline from way back when, like the different eras? And it was probably a long time ago and you may not have ever really learned it either. Does anybody remember? Okay, let me get you a little context here. Let's pull up so see, even us as learners, we have questions as we're reading the article, right? Do you think kids are gonna have those same questions? Like, what is he talking about? The geologic time, Here, let's just pull up one of these. So in geologic time, there were 4 main eras. Okay, so here we go. This, right, all of this time period, and look at the time over here, 4.5 billion years ago, up to 541 million years. All of this time was called the Precambrian, and they don't have it written here. Okay, so we don't have a lot of fossil record because at that time life was bacteria, it was in the sea, it was soft bodied, not a lot of, we started getting like marine type fossils like with shells like clams and that sort of thing kind of at the end of that era. Okay, our next era is the Paleozoic, and then we've got the Mesozoic, and then the Cenozoic. Okay, so big picture, there are 4 eras. Can you guys give me a thumbs up, thumbs sideways, or thumbs down if you understand that? Four main eras. Okay, excellent. And so we live up here in the Cenozoic era. In fact, we live right at the very top of it. That's us today. Okay, so Walter Alvarez, where he was looking was right here in this, at this time period, and right between the Mesozoic and the Cenozoic. Now, I'm sure a lot of you have heard of the Triassic and the Jurassic, and maybe even the Cretaceous. You guys heard of those? Those are all called periods. So again, the eras are further divided into smaller chunks of time called periods. So not to confuse you, but this was a really important time period, and this is where that clay layer was, right here. Now they call that area the KT boundary. Everybody say KT boundary.
KT boundary.
Yeah, KT boundary. And we can see it, this layer of clay in Montana. It's all around the world. And the KT boundary stands for the Cretaceous Tertiary boundary. Now this doesn't show the tertiary, but these two together are called the tertiary. Okay? Cretaceous in German is spelled with a K. So it's K, and then this is the tertiary. So the boundary between the K and the T is that layer of clay that Walter Alvarez found. Let me see if I can find a better one that shows that, just to eliminate some confusion. Here, this one even shows it better. Okay, so right here, this boundary, 65 million years ago is when the dinosaurs went extinct, and that's the boundary in the clay that Walter Alvarez. Again, the K is because Cretaceous in German starts with a K. Okay, so that's a little background, kind of a where this occurred, where this time period was. Okay, so I think that's all I wanted to show you, was just for right now anyway, just that picture of Walter and his father and kind of what that boundary is. Again, what's it called?
KT.
The KT boundary, okay? And so before this time period, the dinosaurs were alive, but this was the cause of a major extinction, okay? So does that help you guys clarify a little bit about what Jenna kind of shared with you there? Some details, hopefully. Okay. So lots of iridium. Do you guys know anything about iridium? Ever heard of that element? Why don't you, really quick on your phone, Google iridium, see what you come up with. What is iridium? Where do we find it?
Says it's a very hard, brittle, silver, white metal.
Okay. And is it pretty common here on Earth?
No, because it's expensive.
Yeah, it's not very common. It's expensive. So why would Walter Alvarez be testing to see if there's iridium in this clay layer? What's the significance of the iridium?
It's in a lot of asteroids.
Yes, it's in a lot of asteroids, okay? So the question is, I mean, how did all this iridium end up in this little thin layer of clay? Okay, all right. Let's go to section 2.
So that was me. And in this section, he starts kind of asking that question of like, where did this come from and everything like that. And also how it's related to the dinosaurs. So first he thinks that it's a supernova because it would have that iridium in it, but it would also have this other element, plutonium. And so they did this experiment and they thought that it had that in it, and they were all excited because they thought they found out what happened to the dinosaurs. And then it turns out that their experiment had been contaminated and there wasn't any of the plutonium. So it couldn't have been a supernova. So then he kind of went back to the drawing board and started thinking what else could have caused all this iridium to be here. And he decided it was an asteroid. So then they started looking at that, and they started thinking that like, how would that have made all these dinosaurs go extinct? And they said that when that hit the earth, it would have blown so much dust into the atmosphere that it would have blocked the sun and made like photosynthesis stop and collapse the food web and make animals go extinct. And they published this idea in 1980. And from then on, a bunch of scientists started publishing papers on the topic from all different fields of science and kind of bringing like new evidence in.
Excellent, Kenan. Now, I have a question. Who wants to share with us if you know what a supernova is? What's a supernova?
Is that when a star explodes?
It is a very massive star. Okay, to be a supernova, the star has to be extremely massive. Our sun will not ever be a supernova because it's just kind of a medium star. Okay. All right. Awesome. Great explanation. So, asteroids. All right. Let's go to side 2, you guys. And we've got, let's see, is it Marka? You've got section 3, right?
Yep.
And you guys can look at your article and kind of follow along as she's telling you.
Okay, so these scientists all kind of had to think of their own hypothesis of like what had happened that long ago, because obviously there was zero documentation of what happened. And so they came up with like a bunch of different theories and then kind of tested each one to see if that actually happened in that time period. And so the first one was extinction. And in order for that to happen, something had to have like exploded and cut off all like sunlight to the earth where all the plants and animals would die. And they did find that there was a large extinction rate at that time, and that probably only after caused. And then the next was impact. So they found that there's a bunch of, something had to cause a bunch of particles to like move around the earth. And if an asteroid happened, which they found all these particles at the KT boundary. So, and only an asteroid could do that. Next, there was glass. After an asteroid hit Earth's surface, there had to been a lot of glass particles get moved around, which they found at the KT boundary. And then the next was...
Do you want to share how that glass got there?
I'd have to look.
It's okay. It's the heating of the rock. So like the rock got so hot, it formed the glass.
Yeah.
So just to make.
And then the next was shock waves. And so they did find, that's why after an asteroid hits the Earth, it's obviously going to shake the Earth's surface or the tectonic plates and everything. And they found a lot of shock waves at the KT boundary, along with a lot of deformed quartz, which is also a good indication. And then tsunamis, if an asteroid obviously hits the ocean or hits the earth, it's going to cause these huge waves to go around. And they found that there was a lot of ocean sediment in the KT boundary. And then finally, there would have to be a huge crater, obviously. And there is one found at the Yucatan Peninsula that dates back to the Cretaceous period.
Excellent. Anybody have any questions on those 6 specific tests that they did that were kind of it ended up being evidence for the theory that they're proposing? Okay, excellent. And last person, Ashley, number 4.
Okay, so mine was just kind of like a summary of everything. And so they knew that the evidence was strong that dinosaurs had been extinct, and that there was a huge iridium spike at the KT boundary. But they said that they have a lot of questions. So even though a lot of observations have support the asteroid hypothesis, the investigation still continues because they don't have enough information. And they knew that into this, that the reason there was so many different hypotheses is that the Cretaceous period was a really crazy period and with a lot of changes. So it the ecosystems were very disrupted. So it could have really been anything. But the factors did have a role in triggering mass extinction, but they still have many more questions. So
Excellent, you guys. Yeah. And so thinking about that Cretaceous period, you guys, we know, again, looking at the rock layers, that it was a very tumultuous time here on Earth. Volcanoes were exploding. We had sea levels rising and falling and little mini ice age. I mean, it was just crazy. And so, that happened. So did those happen because of the asteroid, or were they going on anyway? The volcanoes wouldn't be necessarily from the asteroid. There's something else I want you to think about, even the smoke we're having right now. Think about how that is blocking our sunlight. In the year 1812, it was called the year without a summer. Have you heard of that historically? Why don't you quick on your phone or your computer, Google the year without a summer, 1812. Just go ahead and Google that and let me see what you find out about it.
isn't it 1816?
Oh, it is 1816. I'm sorry. Yes. Thank you.
It says it lasted 3 years, and it was because of a volcano erupting in Indonesia.
Yes. Yes. Does everybody know where Indonesia is? Just north of Australia, a little bit east of Australia, between India, and it's right there in the Indian Ocean. And so it was Mount Tambora. And Mount Tambora is a huge volcano. Well, we didn't have text messages or phones that we could call the folks in England and the United States and say, hey, we've got a big volcano erupting here. So there's a lot of ash in the air. People didn't know what was going on. So what happened? What happened in the 1816? What happened that year? Weather-wise and food-wise, and
You said it was the summer temperatures in Europe were the coldest on record.
Yeah.
And it resulted in major food shortages
yes,
across the northern hemisphere.
absolutely. I mean, if the sun's blocked and it doesn't warm up, we're not going to have a lot of photosynthesis, or near as much as we need. And so crops didn't grow. And I mean, it snowed in places that you'd never think of it snowing in the summer. And so it was horrible. So I want you to just think about that one little incident. That's one volcano, but multiply that and imagine what the earth would be like. So that's kind of what it was like at the end of the Cretaceous. Okay. So I want to show you real quickly. I'm going to share my screen with you again. And I'll just share with you a couple more visuals to help you understand. So this is an artist's rendition of what we think maybe that impact might have looked like. Most people, when you think of a tsunami, when I ask my students or when I think about it myself, and I'm going to ask you guys, do you think of like an underwater earthquake? An underwater earthquake that causes this big tidal wave? Okay, so but tsunamis can be formed by like asteroid impacts or big glaciers calving off. It can form a big tidal wave. But this is an example, an artist's picture of what maybe that might have looked like. Okay, if an asteroid that big struck the earth. This is the Yucatan Peninsula here off the coast of Mexico. And this is where that impact happened. And they do have evidence of that in the water as well, where that crater is located. Okay, so it you know, there's a lot of evidence, but what I want you guys to think of is, remember we talked last week or 2 weeks ago about doing science? Remember we had Marcos and Antone, and do you remember that little kind of bell ringer thing we did?
Yeah.
And we talked about why the scientific method doesn't work most of the time for real science, because it's too simple. Did Walter Alvarez, did he follow this? No. He
Not
really,
really, no.
I mean, maybe parts of it, but it wasn't just 1, 2, 3, 4, 5, and I'm done. Because what happened continually throughout that whole process?
He had to like come up with new hypotheses throughout it because they were getting proved wrong.
Yeah, he was getting different results, and it seemed like I think, Jen, I believe you said that there just were more and more questions. Like you said, every paragraph ends with a question, right? And so instead, I'm going to go to this next slide. This is a little bit simpler. This is the idea of how we think science works. It starts out with that top circle there, exploring and discovering, making observations, asking questions. I wonder this. And this is a really good quote or phrase to use with little kids is, I wonder, and have them finish the blanks, fill in the blanks. But I want you guys to think about, and I don't know if any of you printed that or if you could pull it up under the Doing Science folder, but let's think about Walter Alvarez and where his path may have gone from his original idea back when he was looking at the rock layers and he found that iridium. So let's pretend that he starts up there in that explored and discovery, the pink circle at the top. Okay, wow. He notices this, he wonders what caused the extinction of the dinosaurs, but remember he was in Italy and he was looking at these layers and he was like, this layer of clay that he noticed. And they had dated it back to 65 million years ago. But, you know, noticing the marine life below and the lack of marine life above, what would have caused that to happen? So he asked some questions, and then what did he do after that?
The testing ideas.
Yeah, he bopped down to the testing ideas. Now, if I go back to this other slide, you guys, this will give you a lot more information. Okay, and did he get the expected results he thought he'd get? When he was tried to measure, when he tried to test?
Mm-mm.
No, he didn't. So what happened after he was in the green circle? Then what happens?
You go back to the exploration and discovery.
Yes, he goes back to, and it's like, oh, well, that's interesting. That's not what I expected. So did he at any time ask other people? Did he share his ideas? Did he ask for expert opinions and ideas? Yeah. So do you see how he may have bopped down to that purple circle?
Mm-hmm.
And then again, maybe maybe he went from there to testing and gathering more data. And then again, after that happened, when he found out the beryllium, his dad suggested maybe he look for the iridium, right? So he went back up to the pink, asked more questions, bopped down to the green, did more testing. And I want you to think about how many times and where he went in this whole circle, this whole, I should say, cycle. Can you see how he doesn't, it's not a linear path. And I guess that's with this is a very linear trajectory, whereas real science is not at all. I think it's really important too to understand the purple circle, that we have to have peer review, we have to have other scientists checking our work. And so as consumers, that we're looking at these studies, even like with COVID, who's doing the study? Who's testing it? Who's peer reviewed it? What's going on? Instead of just looking at somebody's idea, you know, how valid is it? And I think it was McKinnon said that in 1980 he came up with that hypothesis, and then it was Mark, I think you were talking about, for those 10 years, how many papers were written? About, it was like 2,000 papers after he proposed his idea.
I think that might have been Ashley.
Was it Ashley? Okay. Yeah, so there were a lot of papers written that were looking at the evidence and trying to verify or dispute what Alvarez claimed. Okay, so and then of course I don't want to forget the circle on the left here, you guys. The what are the benefits and outcomes? So on this particular story, I mean, the title says unexpected twists and an unfinished story. So if we look at what are some benefits that have come out of his research?
He was kind of like the first person to start doing it. So then like more people have started using his research and like building on it. So we know even more.
Yeah, he generated a lot of interest, didn't he?
And he like brought in a lot of scientists too to get more involved.
Yes, absolutely. Yes, and along with both of those things, then, did it increase our understanding of maybe what happened to the dinosaurs?
Yeah.
Yeah, I mean, we know they went extinct then, but nobody's really been able to put a finger on. Now, do we know for sure that's what happened?
No.
No, because it's a theory. And a theory is a very well tested, well thought out, has a lot of evidence, but it's not like the law of gravitation that says, we know if I drop an object that it's going to fall at a rate of 9.8 meters per second squared due to the gravitational pull of the earth, or the gravitational force of the earth, right? Okay, so I'm going to stop my sharing now. So I want you to right now just think about, what did you learn by reading this article? What were some things you learned? You don't have to share them, but I want you to just think about, what did I learn about whether it was science or the process of doing science? I'm going to give you a chance to have some metacognition. Remember we talked about that like 3 weeks ago? Okay. So how does that relate to science? And what is the nature of science? Let me go here to my, so basically you guys did that forum, right? Did you do the forum on week 2 with Paul Anderson? That, did you guys do that? Maybe you did it like right after class or something. I haven't graded them yet. Does everybody know what I'm talking about?
Yeah.
Okay. McKinnon, are you with me?
I think she's
Yeah.
frozen.
Yeah, I am.
Okay. Yeah. So the nature of science. So let's just, I want you guys, because this article ties into the nature of science. What is science? What is the nature of science? What does that mean? And I want to go through and have each of you tell me something about what is the nature of science. We're going to start with Ashley this time. What do we mean by the nature of science?
Do you mean like how, like not following a like set of, like set of rules on like, going through steps? Instead, you're just, putting together an investigation or evidence, and then you come back to it.
That's part of it, but just I want you to think about just kind of the big picture of it's basically like, what is science? What is the nature of it? What's our quest? Why do we care about science? What is it?
Like exploring new things around us.
Okay.
Would that be part of it?
Uh-huh. And as well as exploring them, trying to do what with the natural world?
Like find out more about it.
Find out more. Yes. Understand and find out about the natural world.
Kind of like the why and how of things that happen in the world.
Yeah. The why things happen in the world. Exactly. Good. Who else has something to share about that?
And like continuously advancing us, like we need science to keep learning more, and like with technology and everything, and
Yes.
medicine and all that.
Yes. Okay, I'm going to share with you guys one more slide that I think will sum up, and it's from a different presentation, but I think it sums up kind of what Paul's video was too. So let me just pull it up here and see if you remember learning about this. So it's a body of knowledge and a process. It's exciting, it's useful, ongoing, and number 5, it's a global human endeavor. Why would that be important? What does that mean? Number 5.
Like everyone working together.
It's-
Oh, sorry, Marcia.
Uh-huh.
Oh, you're good. I was gonna say like the same thing.
Yeah. So it's a human thing, isn't it? Do ants do science? Do they have a use for it? Do they have a body of knowledge? Are they trying to understand the natural world? No, they just are trying to survive, right? Okay, so those 5 things, those might be things, I can throw that slide in there. I don't have it in your presentation, but those are really important. And that video that you guys watched about Paul is important as well. Okay, so I can throw that in our presentation. Okay, so we're gonna wrap things up here in just a minute. I wanted to, let me look at the other things I had on the presentation. Okay, one last thing. I know, Jenna, you said you don't have your book available, right?
Right.
Okay, no worries, but what I'm gonna have us do is everybody else has theirs, right? Correct?
Yeah.
Okay. What I'd like you guys to do is turn to page 13, 14, and the top of page 15. Here, I'm gonna share my screen again. And Jenna, you're gonna be our Google checker, okay? So here's what I want to ask you, because remember, one of our goals tonight was understanding what is scientific literacy. Okay, so I want you guys to read in your new textbooks, pages 13, 14, and the very top of 15. Let's see if we can't come up with a definition or a description of what does it mean to be scientifically literate.
Okay, everybody.
Okay, and Ashley, you're gonna Google it for us and find out what it means.
No, Jenna is not.
I mean,
Ashley.
Jenna, I'm sorry, Jenna.
I'm the Googler.
Okay, you're the Googler.
And also, I have to go to my other class, so
Oh,
I'll watch this later.
Okay, Ashley. So
I told you about.
yes, you did. Now, I just want to clarify. Here's what you're going to be doing. Okay, and
I'll take a picture of it.
it's up on Moodle for you.
Oh, okay.
Okay.
I'll take one just in case.
Okay, go for it.
All right. Thank.
Okay, thanks, Ashley. We'll see ya. See you next week.
Bye.
Bye. Ah. So, you guys, it starts right here.
Okay.
Okay.
My ebook is being very slow,
That's
so
okay. And then there's a
Okay.
little link here too, that if you want to look at that.
okay.
You want me to just go to the link?
Yeah. Do you want here? I'll hold it up here for you. It's a little video. It's a little YouTube video. I bet if you just Google scientific literacy, you'll probably get it.
Okay.
And it's Neil deGrasse Tyson. Did you find it?
Yeah, I think so.
When I think of science, I think
Yeah.
of a truly human activity.
And actually, you guys, you don't need to read those others. It's just that little section that's in the text heading that's in blue, developing responsible informed citizens, okay? Sorry, it doesn't go on. How you doing, Jenna? Did you get the video watched?
Yeah.
Okay. All right. So let's come back together, you guys. And when we talk about scientific literacy, this is huge, huge for us as teachers. We don't expect every child to be a scientist, but we do expect them to be able to do what?
Well, in the video I was talking, I kind of liked it. It said like exploring their environment, which like was like their own experience, like experiment as a kid, like to see the world, which is kind of what the video touched on, and I liked.
Mm-hmm. So building on what they know to understand the world.
Yeah.
Okay. All right. Thanks, Jenna. How about McKinnon and Markham? Did you guys get anything out of the little passage that you read?
I felt like a lot of it was like being able to look at scientific issues or like what people are saying and determine if it's valuable and correct and stuff. So like not just reading a headline and agreeing with it, but like doing research about it.
Okay. Awesome.
So I wasn't able to load my ebook, but I did watch like the very beginning of the video, and it like really shows like how important it is to be like knowledgeable of science. Like they're just giving facts about like only so many people think that like antibiotics are effective for viruses, or like some people think the dinosaurs and people were alive at the same time. Like just things like that kind of
Yeah.
opens your eyes as to wow, like
Yeah.
we need to be educated a little more.
Yeah. I mean, it's like every generation is going to have decisions that no other generations have had to make. And so to understand not only the facts, but to understand how, and how to research. I highlighted a couple things that I thought were kind of significant for those of you guys that have your books, but can you see what those key things there?
It's kind of blurry.
Is it blurry? Okay.
Yeah.
So here was something I felt was really important. Scientific literacy is less about what someone knows as it is about how someone knows.
It touched on that in the video kind of too, and it said that like it's different in everybody else's lens.
Yes.
Like when they look at it.
Yes. And so to understand those different perspectives, a scientifically literate person seeks to understand the why or the reasons behind the claims. Like the book used the example of the belt, the waist belt that you can buy for $19.95 and you wear it for an hour a day and your waist trims down. Okay. So an educated person is going to say, okay, where's the evidence? And evidence is a key word. What evidence do you have? Where's the evidence that this waist belt or tummy belt is going to work? Okay, so scientific literacy is not just for scientists. I like this part where it says it informs our big and our small judgments spanning from decisions about our health, our government, and even what kind of shoes you're going to buy and wear. Okay, so being scientifically literate, it helps us make decisions. And I think this is a key thing, you guys, that I would try to use this word with your students. Can you guys read that part I have circled there?
Yeah. What's the evidence?
What's the evidence? So scientific literacy, what is the evidence? That's huge for any kind of claim. Okay? Got that written down? Scientific literacy. All right, we'll finish up here. And I'm going to share my screen real quick. And I'm going to fix that part. Could you guys come up with a definition of what being scientifically literate means?
Like looking at evidence and understanding if it's correct, kind
Okay.
of.
Yeah, exactly. Yep. So learning, let's even just say learning to use evidence to make informed decisions.
Yeah.
I mean, that's in a nutshell. We want to use, and we'll make sure we bold this here. I'll even make it red. There, using evidence, okay? So that's what we want our students to be able to do. What evidence do we have? Okay, let's go ahead in the last couple of slides here. I want to talk to you a little bit about next week. So I think you guys already did that forum, I believe, with Paul, the video, Paul Anderson.
We haven't done that one yet.
Oh, you haven't done, okay, so that must be for this week. That's why you guys were looking at me like, I don't know what she's talking about. Okay, so it's up on Moodle. I wasn't sure if I had put it on week 2 or week 4, but I think you're right, it is on week 4. And then on page 19 in the textbook, so Jen, I know yours is coming, but you'll have time to do it. And if you want to, maybe you can take a picture of the questions from one of your classmates, because one of them is to ask, if possible, try to interview an elementary school teacher. Okay, do all of you know an elementary school teacher that you might be able to interview?
Yeah.
McKinnon, do you have somebody you might be able to call or ask if you could give them a call and ask them some questions?
Yeah.
Okay. And then there's another one that says talk with your colleagues. So you guys could talk amongst yourself if you wanted to, or another group of friends. Question number 4 is a talk with your colleagues about some things. And then, yeah, so anyway, the other ones are pretty easy, but they're not just yes, no questions. It's a dialogue, it's explaining. So there are only 4 questions, but you're gonna write a little bit about your conversations and so forth. So page 19, questions 2, 3, 4, and 6. Okay, so the Walter Alvarez summary is, let me show you that. Whoops, it should say paragraph. I don't want you to write a whole 10-page paper. Okay, just write a summary about what we read about. I want you to just do a quick summary. What was that? What was the KT boundary? How did he explore that? And then I want you to think about how was it he did science? What were some of the things as he went through that cycle, that process? And again, you guys, this is all in the presentation, and I'll put it, I think I already put it up there for you.
Is there a separate Dropbox for that one, for the summary?
Yeah, so here's what I did. I just said if you can just combine them into one, we'll do your questions, and then just put the Walter Alvarez summary, attach it all together, and that way you have one attachment. Does that make sense?
Yeah.
Okay. And then, oh, the bumper sticker. I have to tell you guys about this. This will be a kind of a fun assignment. How many of you like to draw? How many of you like to use the computer?
Definitely not.
And you can do either. You can either draw or use an art program. But let's see. Let me go back. Let me. So this is what your assignment's going to be, you guys. And I think this will be really fun. Let me give you a little background. So I used to have an older car, and I had a lot of really fun bumper stickers. And, okay, where's my picture? There should be a picture on there. Oh, there it is. And so this is an example of like the kind of sticker I would have on there, except I didn't have this one because I really didn't want people honking at me. But I got rear-ended this summer and my car was totaled, and I literally cried when they hauled it away because it had so many fun bumper stickers, and not political, just, you know, fun ones, kind of upbeat, make you think about it. But this is some interesting information about what bumper stickers are. And then here's what you're going to do. You're going to create a bumper sticker. And what you need to do is just take a piece of paper, or if you do it on a computer, you can just do it on a half of an 8.5 by 11 sheet. So all I did was just cut this in half so that I just have the lengthwise half of it. So it's about 4 1/4 by 11 inches. And if you know anything about bumper stickers, and if you don't, you might want to research and just get some ideas, but you can do one of two things. You can have a simple message with a small little illustration, or you can do an illustration only with your original artwork. Now, sometimes people prefer to draw them by hand. Some people prefer to do it all on the computer and use an art program. You could even use, Google has a program, you know, and I know Microsoft does too. You got the paint programs or Corel or tons of different programs, but please don't copy and paste an image from Google and put it in there and claim it as your own, okay? And then the part 2 of the bumper sticker is, what is your slogan or message? Describe it. What does it mean? What are you trying to tell the world? Because basically bumper stickers are a form of communication. So like maybe you want to have one that says, got evidence. You know, something like that. Get lost in evidence, kind of a spin-off on the Montana, get lost in Montana stickers. Something like that, using some of the vocabulary about scientific literacy. Why is it important? Why should we care? Okay, so that's your assignment. Make it colorful, make it neat, and then what I'll have you do is I'll just have you take pictures of it, and you don't have to write your name on the back, I guess, because I won't get to actually collect it from you. But I'm having my students do something similar, but I am having it as a contest, and then I'm going to have the grand prize winner made into an actual bumper sticker and put it on my new car. So the kids are pretty excited about that. But this is really a fun project. And so as a teacher, think about, like, depending on what grade level you have, but you could do like a safety bumper sticker. You know, think about how you might be able to use this assignment in your own class at some point. Okay, so let's go back here. Are there any questions about what is due next week?
No.
Okay. And the last thing I want you guys to do tonight in your notebooks is I want you to do a 3, 2, and a 1. I want you to, again, that metacognition is really, really important. What are 3 things you learned tonight? Two things you're curious and you want to learn more about. 2 things you wonder. And 1 thing I might be still confused about or I have a question on. Do you need them, Jenna?
No, I'm good.
Okay. Okay, now if we were meeting in person, I would actually have a little ticket just like that, and I would have you fill it out and collect it before you left. You guys are probably somewhat familiar with exit tickets.
Yeah.
Okay, so you know that that can provide you as the instructor a lot of information, a lot of feedback, especially on the what are you confused about or what do you want to learn more about? And then even to get that verification of the validity of, okay, good, they got it. You know, they learned what I wanted to teach them tonight. How many of you have something written down about Walter Alvarez? Okay, good. How many of you have a new strategy you learned? Okay, good. How many of you have something about like reading text features or something with reading? Okay, cool. All right. Well, again, I would collect those if we were in person, but it's really an opportunity for you to reflect about your own learning tonight as well. Okay. All right, you guys, we will touch base again next week. And thanks for hanging in there, and you guys are doing great. And I did not correct your most recent things that you've submitted, but I will get in and I will have that done by next Monday for you. Okay.
Okay, sounds good.
Thank
Okay.
you. Bye.
Yes, thanks. Have a good night.
You too.
Ew.
Bye.